I've just done a quick easy thing for you to find the intercepts, okay? I know it looks like it'll be awful, but actually because this is already factorized for you, it's really nice. Because to work out intercepts, you just want one of the factors to be 0. So when is sine equal to 0? Answer, 0, pi, 2 pi. Okay. And in the same way, when it's cosine 0, answer, pi on 2, 3 pi on 2. So all 5 of those are going to be intercepts. Okay? So far, so good? Now, when you're working out the derivative, when you're working out the stationary points, again, you want both factors to be 0. Okay? So here's where my working has taken me, and you can tell me from here. This part here, sine squared x is equal to 0. Right? That means I want sine to be 0. Okay? Which in fact I've already solved. 0, pi, 2 pi. Now, by the way, that means that we've got intercepts and stationary points at the same position. What would that mean? You think about it for a second, okay? Alright, next we have to solve this, okay? So I just rearrange a little bit. You're going to get sine squared is equal to 3 on 4, okay? So therefore, watch out for the plus minus, because I've taken the square root of both sides. So this is plus or minus root 3 on 2. Okay? Now the plus or minus thinks it would make it worse, right? But actually it makes it better, because it just means you've got answers in all of the quadrants. Okay? So who's worked out the stationary points you get from this already? Who's got them? Yep.
3 root 3 on 16.
Okay. That's a y value, I think. This is root 3 on 2, so the base angle is 60 degrees, if you like, which is pi on 3. Then you should also have pi minus pi on 3. Then you should have pi plus pi on 3. And then you should have 2 pi minus pi on 3. I'll graph it for you. Okay, so here we go. Here's my intercepts. 0, pi, 2 pi, pi on 2 and 3 pi on 2 in between. Ta-da, ta-da. Okay? Now, if that's pi on 2, where's pi on 3 going to be? Which is a stationary point. Just a little bit to the left, right? A bit to the left, not halfway, because that would be pi on 4. Okay? So I've got a stationary point here, stationary point here, stationary point here, and here. No, sorry, not all of them. Just 0, not that one. Pi, not that one. And 2 pi. Okay? Now when you go in, you take these x values and you sub them back in to the y values. Okay? You're going to get, I think, 3 root 3 on 16.
Yeah, there's like plus minus.
That's right. You're going to get plus or minus 3 root 3 on 16, depending on which stationary point you get. So I think this one goes up first.
Plus minus.
That's right. So here we go. This is pi on 3, 3 root 3 on 16. This is going to be a max. Okay? So I'm going to kind of come up, and then I'm going to go back down. Okay? And then you get the same kind of thing happening. This is going to be the opposite shape, but you've got to come up to a stationary point. Sorry, it's a bit messy. I'm in a bit of a hurry. Okay. That's your shape, and it repeats. That's periodic. So there's my stationary point there. Sorry, that should have been a stationary point there. That's a bit shoddy. Try that. Stationary point, down, stationary point, and across. Okay? So that's a bit messy. If I had more time, I'd make it more beautiful. But there's your 5 stationary points, and your, 7 stationary points, and 5 intercepts. Thanks, everyone.